So we have completed till fundamental concepts. Today we'll be looking into file IO. IO means input and output. So today's session is on file IO. So whoever please mute. It will be disturbing to others. So before starting file IO, let's. I will share you one of the Linux tip which I know. So the tip is if you add logical exclamation mark before a command, it will execute the previous command with with all the arguments. Suppose you have executed vi user include stdio.h. This is the command you have executed. Then you have executed echo hello world. Then you said cat linux tips.h text. Now so if you add exclamation mark before vi, what this will do is it will replace you with the last vi command which you have executed. So the last vi command which you have executed is this. So now see, it has opened the stdio.h file. So adding logical not or exclamation mark before any command name will execute that full command. So if I say dollar, this is echo exclamation mark echo, it will run echo hello world. So this way you will be avoiding typing the whole command. So if I said this, so it is running the cat linux tip.txt. So this was one of the thing, and you can use, and if you pass this logical not or exclamation mark to sudo, the previous command will be executed with sudo permissions. Suppose if you are running dmessage-c, it will say operation not permitted. So what you will be doing, you will be saying sudo dmessage-c. So instead of that, if you say sudo to run the previous command with sudo. So whatever is the previous command, it will be running with sudo. So if suppose my previous command was dmessage-c, I say sudo logic exclamation mark twice. Now the previous command is prepended with sudo. So sudo plus the previous command. So this is the use case of exclamation mark in the shell script. So this is clear, right? Adding just an exclamation mark to the command name will execute the previously executed command, whatever the previously executed command. So if you have any query in this, you can just ask, else we can continue. So file IO, let's start file IO. Just let me mute whoever it is. So file IO in Linux, everything is a file. Even your directory is a file. Hardware devices is also a file. So all the file IO operations in Linux can be performed with 6 functions: open, read, write, lseek, close, dup. So these are the 6 functions, uh, six system calls which we will be using to perform file IO in Linux. So we'll be looking into each and every system call. So these are the 6 system calls which we'll be using to perform IO, input, out, and output operations on files in Linux. So as the name suggests, open is used to open a file, read is used to read a file, read from a file, write is used to write to a file, lseek is used to perform seeking operation, close is used to close a file, and we'll be looking into what is this dup and dupt. Dup stands for duplicating. So dup is used to duplicate a file descriptor. So before going into opening a file, we should know what is a file descriptor. So a process in Linux can open several files. So it can open several files which can be for reading purpose or writing purpose. So each process in Linux has an array, and this array is used to keep track of the file opened, the file status, whether it is open for reading or whether it is open for writing, and the offset of the file. So each process will have an array, and each member of the array will have this information. So open the name of the file which it opened, the file status, whether the file was opened in read mode, write mode, read or write mode, and the current offset, the position of the file. So whenever this file is opened, kernel what it does is it assigns a position in the above array known as file descriptor. So file descriptor is a index in this array. So file descriptor is a position of the particular file in the above array which contains this information. So file descriptor is nothing but a number, or you can say it's an index in the above array. To the kernel, all the open files are referred by file descriptors. So if you want to perform any operation, you need file descriptors. When you open a file, kernel will give you a file descriptor, and this file descriptor is a non-negative integer. So it is not a positive, it is not a negative value, it's a positive value. File descriptor will always be a positive value. If it is a negative value, it is not a file descriptor. So whenever you open a file or create a new file, kernel will return you a file descriptor to the process. And whenever you want to perform read or write on a file, you will be using this file descriptor, which is written by open or create as an argument. So whenever you open a file, you get a file descriptor, and whenever you need to perform read or write operations on a file, you will be using the file descriptor written by open. So whenever you start a process, there are three file descriptors already assigned to the process. The file descriptor 0 is used for standard input, file descriptor 1 is used for standard output, file descriptor 2 is used for standard error. So these are the three file descriptors already assigned whenever by the kernel when you start a new process. 0 is for standard input, so it can be a keyboard or it can be any other command, or when you use a pipe it can be some other thing. So 0 is for standard input, 1 is for standard output, 2 is for standard error. So these are the values standardized by POSIX, but you should not be using these values. You should be using the symbolic constants. So these are the constants: standard input underscore file num, standard output underscore file num, standard error underscore file num. So this should be used instead of 0, 1, 2. So in future, if the values are changed, so using this will be making your code portable. So if you use this constants, you will no need of worrying about what will be the value in behind. So these constants are defined in uni.std.h header file. So if you want to use these constants, you have to include this header file. So I have included uni.std.h file. I have created a buffer of 256 bytes, and I have a integer variable of length of integer. Then what I am doing is I am writing std out file num. So this will be converted to the file descriptor number. So we know std out is 1. This value is 1. Std err is, so we can just check what is the value in the of this thing. Going to user include grep for. So we have seen that std out is defined as std out is defined as 1. Std in, all these are the macros, and just they are defined 0, 1, 2. Std in is 0, std out is 1, std err is 2. So we are writing, so to find out whether write is a library call or system call, we need to check man pages. We say man to write. 2 is for system call. So write is a system call. Section number 2 is for system call. So the argument for write, first argument is the file descriptor. The second argument is a buffer, and buffer is a void pointer. So it can be character pointer, it can be integer pointer, it can be anything. So void means it can be typecasted to anything. Third one is size underscore t. So size of the buffer. So we have used the same thing. So first we have given the file descriptor of the standard output, and then we have written a message and the size of that message. Similarly, we have using standard error and message and size of the message. So let's compile this. So we have seen both have been displayed on the console. Hello standard output and hello standard error. So what is the difference between standard output and standard error? We have seen in our previous session, we have understood the difference between standard output and standard error. Can anyone tell what is the difference between standard output and standard error? So the difference was we have seen, yeah.
Standard output is buffered,
Yes,
and standard error is unbuffered.
correct. So standard output is fully buffered and standard error is not buffered. What this means is whenever you write to standard output, it will go to a buffer, and when we command it to display on the console, it will display it. So we have to command it to display on the console. So whenever we use write system call, whenever it encounters new line character, it will flush the buffer on the console. So other way is to call flush std out. Whereas with stderr, it will be directly flushed to the console. There is no buffer in between. So this we have seen. std out is fully buffered, and we need to send a command asking it to display on the console, whereas stderr is not buffered, unbuffered. So std out should be used for regular messages, info messages, debug messages, whereas stderr should be used for error messages or diagnostic messages. So this is one of the difference which we have not seen in the previous session. std out should be used for regular messages. stderr should be used for error messages. We have seen the redirect operator in our first session. So when you say command redirect, it will redirect the output to a log file. But when you do this, when you run this, it will only redirect standard output messages. So let's see that. So when I say fd test, by default, it is writing on the standard output. So if I want to redirect the log, redirect the output to a log, I say fd test redirect operator log.txt. In this case, you can see the standard error is displayed on the screen, and only standard output is written to the log file. So when you say redirect operator, it will only redirect the log standard output to the log file. So this is like this command. We say one is for standard output, one is redirected to log.txt. So you can see it only redirected standard output. But if you want to redirect the standard error messages, you can say 2. 2 is the file descriptor for standard error messages. In this case, you can see standard output is displayed on the console, and the standard error is displayed on the is written to the file. So you can change what you want to redirect to a log file using the file descriptor number. If you say 1, but if you don't say anything, by default the standard output will be redirected to the console log file. If you say 1, standard output. If you say 2, standard error. So what if I want to redirect both standard output and standard error? So in this case, we are only redirecting either standard output or standard error. If I want to redirect both standard output and standard error, I can say like this: 1 to output file, to error file. So in this case, we can say like this. So two is one is file descriptor for standard output. Two is the file descriptor for standard error. So now we have two different files. Standard output. Now the standard output is redirected to this file. Standard error is redirected to the other file. Suppose if I want to have a single file for both standard output and standard error, here we have two different files. Suppose if I want both standard output and standard error to be redirected to a single file, I can use this syntax. Two is file descriptor for standard error. I'm saying two should be redirected to one. This means standard output should be also redirected. Standard error should also be redirected to standard output. So this is the syntax if you want to redirect both standard output and standard error to a single file. So let's try that. So /fd test, first redirect operator and the file name outr.txt, and say two is standard error, redirect it to standard output. Now you can see nothing is displayed on the console. Now you have everything in the file. So this way you can redirect either standard output or standard error or both using the redirect operator. Any doubts still here? So we have seen examples of how to redirect either standard output, standard error, or both to a file. So I have deleted that file. So let me save it. So we have seen what is a file descriptor. We have seen that three standard file descriptors. I think we have not seen standard input. We have seen standard output and standard error. Let's see the standard input. Standard input, the file descriptor number is 0. So what we are using is we are reading from here. In this case, we are writing to the standard output and standard error. Here we are reading from standard input and we are writing to a buffer. And how many bytes to write? We are saying size of the buffer, so 256. And finally, we are adding a null character to the end of the buffer. So we may not read the whole 256 bytes. How many bytes we read? And at the end, we are adding a null character to complete the string. So let's run this code. Say I am giving the input from my standard input to the process fd test, and it has displayed whatever we have given from standard input. So we have seen all the three standard file descriptors: standard input, standard output, and standard error. So now let's open a file. How to open a file? So file is opened or created by calling the open function or the openIt function. So we have in our previous session we have seen functions are of two types: library function or system call. So to find out which is this function, you have to just say man open. This is one. So we'll only be concentrating on section number 2 and section number 3. Section number 2 is for system call. Section number 3 is for library call. So man 3 open. So there is no open library call. So there should be an open system call. So open system call. So open is a system call to create or open a file. So you have two variants of open. So first variant has two arguments. The second variant has three arguments. So in the first variant is used when you are opening a file. If you are trying to open a file for read or write operation, you will be using the first variant. The second variant is used when you are trying to create a file. So when you are trying to create a file, you will be passing the permissions here. So this third parameter will be used when you are trying to create a file. So we now know that open is a system call. So both and we'll be looking at open it later. This example will be covering only open. So the first argument to open is the path of the file which you want to open. Second argument is the flags. So when you pass the arguments, open will return you file descriptor. So we know file descriptor. Whenever you open a file, kernel will give us file descriptor. If everything is okay, it will give you a file descriptor. If else, it will give you a -1. We know that file descriptors are non-negative. So file descriptors are only positive values. If you get a -1, this means open has failed to open the file. So on failure, open will return you -1. So the last, as we have seen, the last argument is only used when a new file is being created. So last argument is used only when a new file is being created. The path argument is the name of the file to open or create, and the oflag argument has number of options. The first option is which you have to pass is either of this. Either you open the file in read-only mode, so you have to pass this o underscore read only, or if you want to open the file in write-only mode, you pass o underscore write only, or if you want to open in both read and write mode, you pass o underscore read write. So you cannot use all these three constants. You can either use one of these three constants. So out of these three constants, one of them should be passed here as a second argument. Okay, so either one of the one of them should be passed, and to this one you can add the other constants. So you can or means you can add a logical or, and you can add this following flags: o underscore append, o underscore create, o underscore excel, o underscore trunk. When you add o underscore append, your file will be opened. Your write operation will be happening on the end of the file. If you add o underscore create, it will create the file if it is not existing. But you need to pass third argument to the open function, which will specify the permissions of the new file. If you use o underscore excel, it will generate an error if you are also specifying o underscore create and the file already exists. So o underscore excel is used to test whether the file already exists or not. So o underscore excel is used to test whether the file already exists and the creation of file, and it will create a file if it does not exist. So if you want to verify whether file exists or not, you have to use o underscore excel with o underscore create. O underscore trunk is used to truncate the length of the file to 0. So you have, if you want to delete the contents of the file, you can use o underscore trunk. O underscore non-block is used when you want to open the file in non-blocking mode. So this is mainly used when you're doing device drivers. Blocking operations are there. When in case of files, you will not be having blocking operations. So we'll not be looking into it now. In our device driver course, we'll be looking into this option. So we have seen open takes two arguments when you are opening a file. The first argument is the path of the file. The second argument is the other flag. There are three options, out of which you need to pass one depending on what you want to perform, whether you want to perform read operation, write operation, or read or write operation, and then you can append the other constants to this flag: o underscore append, o underscore create, o underscore excel, o underscore trunk, etc. So let's try to see a simple example. So we are seeing open. So the header file, we need to find out what is the header file. So man header file is fcntl.h. You need to pass fcntl.h if you're using open. So I have added fcntl.h. The first argument to open is the name of the file. So we are passing name of the file as hello.txt, and we are saying open in write only mode. So we know that open will give you a -1 on failure. So we are checking if the FD value is less than 0. Then we are saying P error, open failed. So what P error will do? Can anyone remember in our previous session we know we have seen P error. P error
Open fail then
colon plus
error string.
error string of what?
Open fail.
So when you open failed,
File is not there.
so it will set a variable known as errnum, right? So that will be appended to the this message. String representation of error number will be appended to this message. So if open is successful, we are just printing open file successful, and then we are closing the file. So let's see whether I don't have a file known as hello.txt here, and I'm trying to open the file in write only mode. Let's see what happens. To compile, I use make test open /test open, and it is saying open failed, no such file or directory, because we are not having any file named hello.txt in the current folder. So let's create a file hello.txt, touch hello.txt. So I'm creating a file now. So I have a file hello.txt now. Now let's run the executable again. So the opening file was successful. So we have used open to open a file hello.txt in write only mode. You can change the mode to o_read only, or you can use o_read write. So how can I open a directory? Now we have opened a file using open. We have opened a file. Can we open a directory? We know in Linux everything is a file. Even a directory is also a file. So can I open a directory? Let's see a sample code to open a directory from the. So I'm trying to open home_panther2. To open a directory, you need to pass additional flag known as o_directory. If you don't pass this o_directory, then this will fail. So let's remove that o_directory and check whether this will work. What I will do is I will comment this line. So I'm building this. I have a folder home panther2. So no worries. Let's try to run this code. I have compiled it. So I have no error messages printed. So it was opening the file. It opened the file in without any error messages. So it works. Home_panther2, even if you don't pass o_directory, it works. But if you try to open the file in write only mode, then this will fail. So you say error is a directory. So you cannot open a directory in write only mode. You can open the directory only in read only mode, because you cannot modify any directory information. So you should not open the directory in write only mode. You should open the directory in read only mode. So it is successful. So we have seen open system call to open a file. So I assume if you are using C, if we use fopen to open a file, right? We have fopen library call. So when you say man fopen, it is a section number 3. So section number 3 is a library call. So fopen also opens you a file, and we know open also opens a file. So what is the difference between open and fopen? When should we use open and when should we use fopen? Can anyone guess? We have fopen, we have open. Both will open a file. So when should we use open and when should we use fopen? It's simple. It's simple. Fopen is a library call. Open is a system call. I think now you can guess easily. Okay, let's find out. So first difference between fopen and open is fopen is a library function while open is a system call. Fopen is will provide you buffered IO. So there is a buffered IO. So it will be faster when compared to open, which is non-buffered. So fopen is faster well compared to open. Fopen is portable while open is not portable. So why do you think fopen is portable and open is not portable? Can anyone tell us that if I use fopen it is portable, but if I use open it is not portable? Can anyone guess why is it like that?
fopen is basically library call. So if we can transfer in another system, but this open is a system dependent.
Yeah. So fopen is a C function, C library function. So if I write a code using fopen, if I compile it in Linux, it will work. It will if I compile it in Windows, it will work. But if I use open, open is a system call. System call is only for Linux. So if I write a code with open, it will only compile in Linux and it will not compile in Windows. So that's what open is, environment specific. So fopen, if you use fopen, it is a portable. Whereas if you are using open, not portable. And fopen will return you a file pointer. So it is returning you a file pointer, whereas open is returning you an integer. And if you are having file pointer, you can perform other f functions like fscanf, fprintf, whereas you cannot do all those using file descriptor, which is written by open. So these are the differences between fopen and open. As we are doing Linux system programming, we'll be only considering system calls, will not be looking into library calls. So we have seen an example where we opened a file using Open API, Open System Call. Let's create a file using Open System Call. To create a file, we need to add o_create as well as we need to pass the third arguments, which are the file permissions. So here we are giving all the users read-write permission. So we'll be looking into file permissions in any other session, but here we are 666 means read-write, read-write, read-write. So we are opening a file hello.txt in write-only mode, and we are also saying create this file and use the permission 666. So let's try to run this code. Let's remove our existing file, compile this file, open create. Now let's see whether we have the file hello.txt. Yes, we have the file hello.txt created. And let's look in the permissions. L will provide you more information, and you can see it created RW, RW, and R. So it has added a mask, which we will be seeing in our upcoming classes. UMask. What is UMask, and why is the permission not same as the permission which we have given in the C file? So it has given 664. It has not given 666. This is because of a value of UMask. So it will subtract the final value with 2. So 666 will become 664. We'll be seeing that later. So we have created a file using open system call. So with open system call, previously we opened it. Now we have also created a file. So we have seen in our notes that O_execl is used to check for the permissions, to check whether the file exists or not. O_execl, if you add O_execl into the second argument, and if you have O_create, open will fail if the file hello.txt is already present. So open fails if the file hello.txt is already present. If the file hello.txt is not present, then open will create hello.txt. So with o underscore exel, you can check whether the file exists or not. So now we have the file hello.txt here. Let's compile this. So open is failed with an error, file exists. So we have already a file hello.txt, hence open failed. Let's remove this file and check what will happen, whether it will give the same error again or not. So now the file was successfully opened. Let's verify whether the file got created. Yes, the file got created. So with o underscore exel, adding o underscore exel to the flags will give an error if the file already exists. If the file is not existing, then it will create, as you are passing o underscore create, the file will be created. So o underscore exel will always be used along with o underscore create. So this both should be used in conjunction. So the next example, suppose let's add some information to this hello.txt. I'm adding everything in Linux is a file to hello.txt. Now the hello.txt has this content. Now let's truncate. Truncate means delete the contents, and the size of the file will be 0. The size of the current file is 30 bytes. When I open the file in truncate mode, the size of the file will become 0. So I'm opening the file in write-only mode, and I'm saying truncate. When I say truncate, the size of the file will become 0. So truncate is a flag which will say truncate the contents of the file. Let's compile this. So currently I have the file size 30. Let's truncate it. So now let's verify the size. The size of the file became 0. You can observe the size of the file, so became 0. So if you will be using this flag o underscore truncate when you want to create a file freshly, you don't want to use the existing contents of the file. You will be using this truncate when you want to delete the contents of the file and you want to freshly start using the file. So this is the way. So we have seen o underscore create, we have seen o underscore trunc, we have seen o underscore excel. Different flags as a second argument, which is odd with o underscore write only, o underscore read only, o underscore read write. So any doubt still here? So let's move further. The next system call which we are looking is open@. So let's find out what is open@. So open@, to open a file relative to a directory file descriptor. So you can see the third, when compared to open and open@, is having additional argument. So for open, you used to have only 2 arguments, path name and flags. But open@, you are having additional argument. You can say the name of the argument is directory file descriptor. The first argument is the file descriptor of the directory. So let's find out. Let's read more. So we already have seen the difference between absolute path and relative path. Absolute path is a path starting from slash, whereas relative path is a path from the present working directory. So if you are in home user 1, if you want to move to documents folder, you say this is the example of using relative path. But if you are using from slash home user one, this means you are using absolute path. Absolute path is a path starting from slash. So what are the differences between open and open@? So this is the argument which will differentiate between open and open@. If you're passing, so there are three possibilities. If you're passing an absolute path means the path starting from the slash, then this argument is ignored. So when the path parameter is an absolute path name, the first FD is ignored and open@, behaves like a open function. So open@, will behave as an open function and you're passing an absolute path. If you're passing a relative path means from the present working directory, then the FD parameter will be the starting location of the file system. So this should be pointing to a directory. The file descriptor should be of the directory here. So if you are using a relative path, and if you are using a relative path, and if you are having AT_FDCWD as a value here, so this is a special value AT_FDCWD, then the path name will be current working directory. So if you are passing AT_FDCWD, and if you are saying if giving relative path, it will look into the current working directory. If you are not giving AT_FDCWD, and if you are giving a file descriptor, then the path will be using that particular path. So relative path will be from that particular directory file descriptor. So these are the three different possibilities. If you are using an absolute path, then open and open@, are same. If you are using a relative path, then depending on the value of the first argument, if you pass FD_CWD, it will be using the current working directory. So let's see an example of all of them. So before that, let's use this example to understand. So get CWD. Let's find out what is get CWD. Man get CWD. So get CWD is a library call, and it will give you the current working directory. If you pass get buffer and the size of the buffer, get CWD will return you the current working directory. And the path is an absolute path. It will give you an absolute path name. So we have seen what is a get CWD. What is a CHDIR? So let's again look into man pages. Man CHDIR. CHDIR is not a library call. It is a system call. And if argument is a path, CHDIR changes the current working directory of the calling process to the directory specified in path. So whatever you give in this argument, the current working directory of the process will be changed to that particular path. So with CHDIR, you are just running CD command. So on the shell you will be doing CD, but from the program you will be using API known as CHDIR. So in this example, we are first printing the value of current working directory. We are getting the current working directory in PTR, and we are printing the value of current working directory, and then we are changing the directory to whatever the argument. So let's verify whether CHDIR is taking absolute path or relative path. So it is not saying anything regarding absolute path or relative path. It's just saying whatever you specify in the path, that will be changed. So it means it accepts both absolute path as well as relative path. Then whatever the argument you're passing, CHDIR is using that, and then we are printing the current working directory. So I say make cd pwd, and I say cd pwd temp. So first it print the current working directory, which is this, and then it has changed the current working directory to temp because we have passed that as an argument. So in this example, we have seen one of the system call known as CHDIR, which is used to change the current working directory of a calling process. So it will not change the working directory of the shell. It will only change the current working directory of the process. Once the process is terminated, the current working directory will be the same as whatever you have before you run the process. So the first, in this example, we are changing the current working directory to temp, and then we are calling openet. First argument we are saying fdcwd. So fdcwd is a value, is a special value which points to the current, which is a file descriptor pointing to the current working directory. And here you see we are giving an absolute path starting from home directory, from the slash. So when we give this path, absolute path, then this argument is ignored and openet will behave like a open call. So here we are creating this file hello.txt. So I say make, let's give this current path, have a different path there. Cd. I have given this path. I don't have hello.txt. I have a hello.txt. Let's remove this. Let's compile this. So openet failed because it's a directory. So let's see this. What is the error here? Because we gave the name of, so we are trying to open a directory. So we should, instead of creating a file, so you have to give the name of file here. So current working directory was changed to temp. Let's see where the file was created. So file is created in hello.txt because when you pass an absolute path, the first argument is ignored. Okay, we have seen that. The second difference was when you pass a relative path. So if you pass a relative path and if you pass at_fdcwd, this file will be created in the current working directory. So you are changing the temp. Even if you change the temp, when you change your directory to temp, means your current working directory is /temp. Now when you create this hello.txt, it will be created in temp folder. So if I see if I am temp hello, I don't have any temp hello.txt in temp folder, and I have it here. I don't have it here. So let's verify where is this file being created. So first, in the first API was we change the current working directory to temp, and then we call openet to create a file. Let's verify it where it created. It is not created in the current working directory because we have changed the process current working directory to temp. Now let's verify whether it got created in temp. Yes, it got created in temp. So we created a file using openet by passing first argument as 80, what is it? Passing the first argument as 80_fdcwd. So this was one of the difference between openet and open. Let's see one more difference. So here we are passing, instead of passing 80_fdcwd, we are passing the directory file descriptor. So I'm opening, let's change this, open Panther 2 and say Linux system proc. So first we are changing the current working directory of the calling process to temp. Then we are opening a directory and we got the file descriptor. And then we are using the directory file descriptor as the first argument. And then we are creating a file hello1.txt. And let's see this. So in this case, it should not be created in temp. Instead, it should be created, the file should be created here. So we have successfully changed to temp directory. Then we have opened the directory and also we have created a file using openet. And the file got created in the location here. Where is that file? Just a second. It got created in the location hello1.txt because we gave this location in our example home Panther 2 Linux system programming. This was the location which we gave and it got successfully created. So we have seen examples related to openet, chdir and close till now. So I think we cannot complete further. You have any doubts still here? If you have any queries, because we have limited time, we cannot complete the remaining system calls. We'll be looking tomorrow. If you have any queries till in our today's session, you can ask. You have any
Can
yes.
you please explain the last example, this directory FD one?
Yeah, sure. So the difference between open and openet is the first argument. The first argument is the file descriptor. It can be the file descriptor of the directory, or you have a special value known as at_fdcwd, which means it is a file descriptor of the current working directory. If you want to create a file in current working directory, you can use at_fdcwd, and the current working directory can be changed using chdir. So if you don't use chdir, the current working directory will be the same as where the process is present and the program is present. But if you change chdir, this value will be changed. So here in this example, we are using the file descriptor of a directory. So I'm opening a directory. So this is a directory, and I have said open in read-only mode. I got the file descriptor of a directory. Now I'm saying open at this particular directory, this file, and create. So create this file at this particular directory. Clear? I'm asking to create hello1.txt at this particular directory. Instead of using openet, we can create at any place. Whereas using open, we can only create in our folder, or if you pass an absolute path, you can create anywhere using open also. So if you are passing an absolute path, both open and openet are same. But if you are passing a relative path, then there is a difference.
Okay.
Any other queries? Okay, then that's all. Good night, everyone.